Welcome. We are doing another video for Specialist Math Stage 1. We're looking at Chapter 4E, and this is modeling using trigonometric equations. So many types of periodic functions are sinusoidal, which means that they can be modeled using the general functions for sine and cosine. So they have a sort of shape that looks like a sine or cosine wave. All right. So just if we were to use sine, for example, just a reminder, sine starts at 0, 0. Cosine starts at the maximum, in that case would be 1. But as you see, we're not going to have functions that start and end at 1 minus 1. We're going to values that are going to be affected by the data. So remembering how the general function works, A is the amplitude. We can actually use from our data the maximum minus the minimum over 2 as the amplitude. That's how far up and down it will go. B is related to the period. In fact, I just wrote it out as 2 pi divided by the period. That's what B is equal to. C is related to horizontal displacement. So we're going to look at, for sine, you'd actually work out where the middle points are, and you'd kind of shift that across to basically where the x equals 0 or time equals 0 in many of these cases, and we'll work out how far that is. For cosine starts on the maximum, so we need to be moving. We consider where the maximum has moved, I should say, rather than moving the maximum. D is the principal axis, so that's actually the middle point. It's also how far the graph is going to be displaced vertically, but the principal axis can be read as the average of the maximum and the minimum. All right. So there's a few examples you can read for yourself in the book, and they go through how to go about doing this. Okay. So, and they've got plenty of examples how this stuff works. Okay. So we're going to have a look at data, and we're going to have a look at, okay, so I've decided to pick question 2 here. All right. All right, so in this one, we're actually being asked to use the cosine function. So we're saying the monthly temperatures of Christchurch, New Zealand. Okay, find a cosine model for this data in the form of t equals a cosine b, t minus c plus d. Okay, so, all right, now we're going to try to do this without technology. And then we're going to put the function into the calculator and see what we can do with that. So I've actually already loaded in the data here. All right. Now, it might be helpful to mark down, you can do a rough sketch of this, but the way we're interpreting the month is we're going to count these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And to save myself from copying that out, maybe I'll just bring up my calculator. I'm not going to solve for the function this way, but I'm just going to have this here just to see. Okay, so there's the list. So that's your time. So how many months before, after basically the start? So we're starting at 1, January equals 1, and this is the average temperature, mean monthly temperatures. Okay, so we're going to be try to solve for all the values. Okay, maybe I'll just put you here somewhere. There we go. All right, so 11, and there's actually one more value after that. But insofar as, okay, the values here, so we're actually using the cosine function. So remember, cosine starts at the maximum, but we might just look at some of the other ones. First of all, let's work out what our max and min are. Our maximum value, maximum occurs when, okay, let's say is, all right, so it looks like the maximum occurs in February. Okay, so that's in terms of data point, that is 2 and 16. 16 being the temperature. The minimum is all right, what's our minimum is July. And that is, okay, so January is 1, 2, 3, 4, 5, 6, 7. Of course, July 7. 7 and and then seventh month. So 1, 2, 3, 4, 5, 6, 7 is also 7. All right. So we can use that actually to solve for a couple of these. We can use them to solve for the amplitude. So if I was to take this, I'm going to say my A is going to be equal to the maximum minus the minimum divided by 2, 4.5. Okay. Now, the thing I was actually thinking before I started this, how I was actually going to do the period. I think we're just going to use the fact that we're going to presume the period is 12, because you don't actually have a repeated value, so you never actually see it go back to another set value. So it's not immediately obvious. Another way you could actually approach is to consider the fact that, okay, the maximum typically occurs then you go down to the minimum, and that's half a period. The problem with that is, if we look at that, we'd actually have the time from the maximum temperature to the minimum temperature is actually 5, not 6, which it should be. So I'm going to presume the period. This is the amplitude. The period I'm going to presume is 12 months. So that makes some sense to how we understand seasons. And thereby, your value for B is equal to 2 pi divided by, excuse me, 2 pi divided by 12 is pi on 6. That's what I'm going to put as my B value. Okay, so I've got my A, my B. D is probably the next easiest one to get. Okay, and then we're going to consider where this is and where we're going to start it. All right. Okay. D is your principal axis. So min plus max over 2. Okay, min plus max over, there we go. 16 plus 7 over 2. That is 23 over 2 is 11.5 is my value for D. All right. So let's let's try and see if we can think about C. So remember, we're not doing sine, we're doing cosine. Cosine starts at the maximum, but the maximum here occurs at t equals 2. So that means the maximum has been shifted. So cosine usually looks like this. It starts at 1 and goes down to -1 and comes back up on a period. Okay, and that's this principal axis. Okay, that's your cosine. All right. So we're actually going to shift this across to 2. Now, we've also got something changed in the period, so I'm always a little bit careful with the way I represent this, but I think it's still correct because the idea that when x equals 2, that this part's 0, so therefore that part doesn't matter. If you think about where you've shifted the graph, so if I go to the right by 2, I need to, minus 2. I'm thinking C is equal to 2. We'll check to see if I've got this right. If it graphs well on top of the data, then I can presume that I've done this well. If not, then I'll have to look at some other options. Okay, so let's have the function then would be, okay, so I want to write the variable as t approximates 4.5 cosine cosine of bracket pi on 6 bracket x take 2. So that, notice how that's outside the bracket. So this is going to affect that as well when it comes to, yeah, well, it's going to affect the period. In that respect. So I'll see how that works. Hopefully this is going to be fine. And then plus 11.5. Okay, so first of all, let me show you how to plot bivariate data, so an x and a y, as a stat plot. First of all, put your data in here. Then go here to stat plot. You're going to turn your plot on. Make sure you pick the correct list if you've done something different. Actually, I'm not entirely sure how to change the list. Oh yeah, you can do it by doing that. So I'm actually going to turn on because I've actually got the correct list in place. All right. Now make sure you go to window and you set something appropriate. I've already set this up. 0 to 12 and 0 to 17 for my Y. That's my temperature. All right. And that's what it looks like. That's your data. Okay, you see that there. Now, I'm going to do a Y function. I'm going to put it here. So I'm going to put in the Y function we just worked out. So 4.5 cosine, okay, where's my pi? My pi is there. Pi on 6. I'll put another little bracket in here. Okay. All right, that it's all right. So we seem to get a fit here. That seems to be where we've chosen to displace it seems to, like, if we shifted it back a bit more, it'd be a better fit. It fits this point very well. Now, probably another way to think about it, maybe I'll try a different C and see if it makes a difference. So I focus this on where the minimum curve. Now, in terms of that, otherwise, okay, it's a little bit like, yeah, it feels for most of the points it's the function is ahead of the curve, but it fits this point very particularly. But that's the one I focus on. Okay, 11. I could just have a look at my data and see if there's something else I could pick up. We don't have 11.5 in the data. We do have a minimum point, so I use that as a minimum. I'm kind of curious. So if I think about the cosine, all right, the minimum is here. All right. Now, in terms of that, the minimum occurs, well, in terms of the cosine function, minimum occurs at pi, which has actually been shifted to 7. So we've gone from 3.14 to 7. I'm not exactly sure if this is going to work. I'm just going to try something. Let's just go into our Y function, see if we can write a better one. Okay. So I'm going to insert here pi, 7 minus pi. Actually, I'll just put this as not insert. Here is 7, and then I will insert 7. Actually, I'm going to be subtract this whole thing, so I'll put a bracket there. Bracket. 7 minus pi. I'm not sure if this will work. If it doesn't, I'll just forget it. If it does, I'll explain what I'm doing here. Nope, that's not going to work at all. Probably because I missed the bracket. There we go, sorry. I'm clicking and nothing was happening. Yeah. No, I didn't. No, I didn't. That's just not going to work. Probably because of that scaling factor here. Yeah, you've really got to focus on like where the initial value occurs. Unfortunately, this doesn't look too good with the 3 that I did. Did I do 2 or 3? Let's just see that. Oopsies. Wrong function. Here we go. All right, let's just undo that and we'll go back to what we had before. Delete, 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 delete. Okay, that was 2. All right, and that gave us this. All right, so all right, it looks like it lags. I mean, you could actually make it a little bit better, but doing that, but yeah, it does actually fit the maximum very well, but doesn't fit the rest very well. So there's that. Now there is actually a way to actually create a model. I'll show you how that works. If I go into, I'm going to go back into stats and I'm going to go into calc and I'm going to go right down here, right down to sine registry. Now there is no cosine registry, unfortunately. There is a sine registry, but remember you can change sines into cosines without too much difficulty. Okay. I'm not entirely sure how to use this well. I'm not entirely sure if this will work. So maybe I'll give this a try, see if it does something. I'm going to do stat. No. DaVinci, I tried this previously. Try it again. Sorry. Calc. Okay, sine registry. List 1, list 2. I might even see if I can set that with the manual period of 12. I did this without it, and I did actually get a value that seemed to work okay. But let's have a look. Okay, so I'll write this down. All right. So in that case, we're getting some values that do look similar. Okay, so their value of A, so their calculation was T approximates 4.2. I'm going to round to 3 cent figures. There's this sine though. Now sine and cosine are related. It's a little bit tricky to try to convert them in this format though. But there is a relationship that does work in that respect. You can kind of add, I think you add or subtract pi. If you squeeze it in there, it would actually work. And if you simplify, you can actually get it out. Also, be careful the format. That B doesn't have an extra bracket if you look here. And that's always a point of confusion when I'm doing this stuff. Okay, so they got B, we got sine of 0.533 x, so there's no extra bracket there. This is their one. That's the format they use. Plus 0.6766 plus 111.18. Now they've used the calculators use an algorithm to come up with this. It actually will be superior, I imagine, to the one that we've done, but ours was a pretty decent approximation anyway. It was a little bit off, but we'll see how we work. Now I'm going to put that into my Y2. I'm just going to type it in. There was a way to copy it out, but I'm not a master of this stuff, so I'm just going to quickly type this out. Sine bracket 0.35, 533 x plus 0.766 bracket 11 point. Okay. So yeah, this is better. All right. You notice that actually the maximum kind of occur. It looks like a maximum occurs more in January. So it actually doesn't fit that part too well, but it fits the data better than R1. But yeah, that's how you can actually go about doing it if you want to do this with a graphics calculator. So look, have a go at these. It's all about approximations, and the nature of data is, well, we do models, and we use the models until they break, and that's what models are for. We can make predictions for short periods of time, long periods of time. Extrapolation models become less reliable over time. But you can use those techniques. Have a try at some of these questions here and see how you go.